Students, so now we are going to discussing about quantum numbers. Quantum numbers give an information about orbit, orbital and electron. There are four types of quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. First of all, principal quantum number. Principal quantum number was proposed by Niels Bohr and it is denoted by small n. Principal quantum number explains about, gives an information about orbit, maximum number of electrons filled or accommodate in an orbit is equals to 2n square, where n equals to orbit number. For example, if n is equals to 1, 2 into 1 square, that equals to 2. That means in the first orbit there are 2 electrons are present. If n equals to 2, 2 square. 2 square means it's 4, 4 2s are 8. In second orbit there are 8 electrons are accommodated. In third orbit 18 electrons are accommodated. In the fourth orbit 32 are accommodated. This is about principal quantum number. The second quantum number is azimuthal quantum number. Azimuthal quantum number. Azimuthal quantum number was proposed by Sommerfeld. It is denoted by small l. Azimuthal quantum number is also called as angular quantum number. It gives in information about subshells or orbitals, shapes of orbitals especially. Principal quantum number was starting from 1. If n equals to 1, that is k shell, l shell, m shell and n shell. Here l value starts from 0 because we have the formula to get l value, l equals to n minus 1. If l equals to 0, that is s orbital, the shape of s orbital is spherical. If l equals to 1, that is p orbital, that is dumbbell. If l equals to 2, that is d orbital, shape of d orbital is double dumbbell. If l equals to 3, that is f orbital, it has 3D structure or complex structure. We can't draw on board and paper. Maximum number of electrons filled in a subshell, we have the formula is 2 into 2 l plus 1. For example, if l equals to 0, that is s orbital, how many electrons are filled in s orbital? So 2 into 2, l value for s orbital is 0, we know. So 0 plus 1, 1, 2 into 1, 2 electrons are filled in an s orbital. In the same way, if l equals to 1, p orbital, 6 electrons are filled in p orbital when we substitute 1 in presence of l. In this way we can calculate. The third quantum number is magnetic quantum number. It was proposed by Mr. Lande. It is denoted by small m. It gives an information about orientation of orbitals. To get the number of m values, we have a formula that is 2l plus 1. So for s orbital, how many m values we can get? for s orbital, L value is 0, we know. Number of m values 2 into 0 plus 1, that equals to 1. M values can be written from minus L to 0, minus L to plus L through 0. M values can be written from minus L to plus L through 0. So for s orbital there is only one value, that value is 0. That's why we are saying when L equals to 0, M also 0. When L equals to 0, M also 0. We can calculate for p orbital also. For p orbital, L value is how much? 1. Okay, for p orbital there are 3 values we are getting: minus 1, 0 and plus 1. So those orbitals are like this. For example, if it is an x-axis, the orbital is known as px orbital. If orbital is lying on y-axis, that is py orbital. If it is on z-axis, that is called pz orbital. So for d orbital, L equals to 2, 5 m values we are getting. We can be written from minus L to plus 2, minus 2 to plus 2 through 0. There are 5 d orbitals, double dumbbell shape. Among 5 d orbitals, 3 orbitals are lying in between the axes. Like this. It is dx orbital because it is arranged in between x and y. It is dyz. It is dzx or dxz. There are 2 orbitals which are lying along the axis, like this: dx square minus y square, and another is dz square orbital. Sorry, dz square orbital. When square comes, that orbital is present along the axis. The fourth quantum number is spin quantum number. It was proposed by Uhlenbeck and Goldschmidt. It is denoted by small s, and it explains about spinning of orbital, spinning of electron. The quantum number which only explains about electron is spin quantum number. According to spin quantum number, electron rotates in 2 ways, in 2 directions. One is clockwise direction, like this. To represent clockwise direction of electron, we write electron in upward direction. The spin value for upward direction electron is plus half, and another one is anti-clockwise direction. Sometimes we called as counterclockwise direction. It is in anti-clockwise. To represent that, we write a downward arrow. Its spin value is minus half. Here, plus and minus are not mathematical quantities. It explains the rotation of electron, spinning of electron. This is about spin quantum number. So these are the 4 quantum numbers which are very important to write in examination. Thank you, students. Comment if you want any chapter or if you want any concept. Thank you very much.